Hi guys. Um, some years ago I made this video and I'm going to make the same video again. It got removed twice on YouTube, but since then other people have replicated this experiment and posted their own, and theirs are not getting taken down. Plus that was a long time ago anyway. So what I want to do here is make a new video showing you what other people have replicated so you can see it with the original two James Roney Stators. I have two of them here, and I'm going to show you a little bit of detail about how this is made. What I want to show you here first, what you see in other videos of people who have replicated my work, shows you, let's see here, shows you when you get them close to each other, one pushes the other away. Okay, so just like that. Let me put this here for point of reference. Okay. Okay, anyway, you get the idea. Okay, now turn around and now watch what happens. Doesn't want to do anything. What I've done is I've deadened the back. I've shielded the magnets. Okay, what's going on here is that in the middle of this I have a 1 inch by 2 inch by 1/4 inch neodymium magnet. And of course in here in the middle I have the same. Now this one's a little bit more compact than this one. I made this one first and I made improvements upon this one. This has a little bit better performance. And when I take a screw, you'll notice it doesn't stick to it. Okay. This is the top. This is the top that faces the armature magnets. Okay. And doesn't stick here either to the back. Obviously because that's the back side, it has no magnetic field right now. So what I'm going to do is I'm going to flip this over, which is the back side. It's the bottom. We don't really use the bottom, so it doesn't really make much difference. But I'm just going to show you that this indeed is truly a magnetic screw. You can see I can pick up the stator that way. Okay, and the other one too. Yeah, I made this one better, so it's better. It's shielded better on the bottom than my first model. Okay, so anyway, and then you flip this back over, and then voila, you have nothing. You don't have any attraction. It's just not there. Okay, and of course, on the back side of this, no attraction either, as you can tell. Oops, hands in the way. Okay, now, with a closer look here, you'll notice here, let's see if I can get a good look in this for you. You'll see the 1 inch magnet in there, okay? And you'll notice here, there's spacers, little plastic spacers. Plastic spacers is the same thing here that comes with magnets when you buy a few of them at a time. Okay, so now what we got here, look real closely, there's shielding right back there. Do you see that back there? It's way back here, but you'll see it right there. Right there. So this shielding goes over top of these spacers right here. Okay, and then I put paper in here to create bulk. And then there's another piece of shielding right there. See it? Yeah, there you go. See that sharp corner right there? Okay. And then more paper space, and then one last layer of shielding up top. Okay, so we have 1, 2, 3 layers of shielding. Each is spaced about 1/4 inch, maybe a little less apart. These 3 shieldings, because they're spaces, deadens this. And that's what some people on the web are onto. They realize that my spaces make and break this. So with a triple layer and triple spacing, we have, well, yeah, triple spacing. You have a spacer right, space in here, and space in there. So anyway, that's what really makes this work. And on the back side, I don't know if any of you all have ever played around with alkaline batteries, with magnets, but they are very magnetic. So I use 2 batteries in the back here to deaden the field back here to really make sure that there is no mode of attraction from the powerful N42 neodymium magnet on the inside here. Because you can see, you know, they have a long range of effect. This is even a further long range effect, but the drag on this cardboard is causing it to not slide so easily. Okay, so the way these work, as you can see now we're back to just dead. Okay, so I got this right. There we go. So the way this works is that we have the open face, open end of the magnets. So we have here is the magnetic raw attraction of the magnet, of one magnet. Let's say this is a magnet. Because if I use a real magnet, this thing's going to jerk right toward the other magnet. So let's say this is the magnet, and it comes to it, and we have raw magnet, the attraction of one raw magnet to another raw magnet. And so what happens is it pulls it right towards it, but it pulls it over top of it. As it goes over top, we no longer have magnet to raw magnet attraction. We have magnet to steel attraction. So the attraction on this side, as you know, is far less than the attraction on this side. That means, if I'm only doing approximation or guessing, 60% versus 40%. There's a difference of unbalance of 20%, 40 on this side, 60% on this side, which is what I believe these stators achieve. Someday we'll get real equipment and do real measurements, but I don't have access to that kind of stuff. Okay, so as it goes here, real strong attraction, and on this side, a lesser attraction. This allows whatever you gain this way in speed, it doesn't all cancel out. Because Murphy's law states that Newton's law, for every action, there's an equal and opposite reaction. That's Newton's third law, by the way. So on this side, we have extremely strong attraction. And on this side, we have a weaker or lesser attraction, which means the opposing or opposite attraction is not as great as it is on this side, which means Murphy, when he came up with his third law, Newton, when he came up with his third law of motion back in the later 1600s, over 300 years ago, the technology that I'm using here today and what I'm doing didn't exist in his mindset. We're 3 centuries later. Okay, so back in the day when he was born, everything has an equal and opposite reaction applied. But I've defied that now. The attraction on this side is far greater than this side, which is far lesser. It's not equal. It's a lesser attraction here and a greater attraction here. Murphy's law says it would be equal here and equal here, but it's not. Okay, that's what makes my wheel turn around and around. I'll get it back up and running here shortly. So anyway, that's basically the long and short of all of this. So that's why I put this video together. So hopefully for those of you out there who are trying to replicate my work, some of you have written me, I'm so sorry. I get hordes and hordes of mail, and I mean hordes of it. Right now, my phone says I have over 82,000 pieces of mail to go through. Obviously, I can't go through all of that. So anyway, if you're going to write me and I don't respond back to you within a week or two, then your mail is buried. Okay? And just try again. Otherwise, just message me. It's probably the best way to go. Just message me here within the group, and I'll do my best to respond in a timely manner. Remember, though, I get a lot of people asking me a lot of questions, and I only have so much time to keep up with this and my day job and doing other things that I've got to get done. So, okay, anyway, this is my James Roney Stator, and good luck in replicating it. You can always watch my video called The Secret Behind the James Roney Stator. I'll put that link down here as well, so anybody here is really serious about making some headway and making a magnetic motor, you'll need to watch that to replicate my stators. All right, that's it, everybody. This is January 7th of 2018. Take care, and thank you for watching.